This is problem number 8. Let's simplify this algebraic expression and transform this complicated expression into a simple algebraic expression. Like us and subscribe, and let's get started. If you don't understand any theory which is used for solving this problem, you have to watch my algebra playlist. After watching this playlist, you can begin to solve with me these problems. First of all, when we look at this problem, first of all, we note that this polynomial in denominator has discriminant, which is b squared minus 4ac less than 0. That's why this polynomial doesn't have roots, doesn't have real roots. And the second thing is that this polynomial in numerator of the second fraction, we can write it as p. We can take p out of this expression, so it will be p times p squared minus 3p plus 8. In this case, for this polynomial, we also have a discriminant less than 0. That's why this polynomial it very likely that this polynomial divides this polynomial. That's why let's perform division, and let's divide this polynomial by this polynomial and find a quotient. We will perform a long division, so let's divide p cubed plus 4p squared plus 10p plus 12 divided by polynomial p squared plus 2p plus 6. We write here p, and when we multiply this p by this polynomial, we will have p cubed plus 2p squared plus 6p. And after subtraction, we will have here cancellation. It will be 2p squared plus 4p plus 12. And here we write plus 2. And when we multiply this plus 2 by this polynomial, we will have 2p squared plus 4p plus 12. And after subtraction, it will be 0. That's why this polynomial can be represented as a multiplication of this polynomial by this polynomial. And we can rewrite our problem and write this our polynomial as multiplication of two polynomials we found. Our problem will be as p plus 2 times p squared. I'm writing this here. P squared plus 2p plus 6. And rewrite this polynomial. It will be p cubed minus p squared plus 2p plus 16 times. Here we rewriting this. It will be p times p squared minus 3p plus 8 over p squared plus 2p plus 6. And great, now we can see that we have cancellations here. Let's rewrite our problem, and after cancellation, our problem will look like p times p plus 2 times p squared minus 3p plus 8 divided by p cubed minus p squared plus 2p plus 16. It's easy to see that this polynomial of degree 1, p, does not divide our denominator. And since our denominator is a polynomial of degree 3, it's likely that it can be divided by this polynomial and this polynomial, because this polynomial times this polynomial gives a polynomial of degree 3. This is polynomial of degree 1 times this polynomial of degree 2 gives us polynomial of degree 3. And it's very likely that multiplication of these two polynomials will be this polynomial. Let's check it and divide our polynomial p cubed minus p squared plus 2p plus 16 divided by p plus 2. The result will be p squared. Here we have p cubed plus 2p squared. After subtraction, we have a cancellation here. We have minus 3p squared plus 2p plus 16. And of course, here we have minus 3p. It will give us minus 3p squared minus 6p. After subtraction, it will be 8p plus 16. and which gives us here plus 8. And when we multiply 8 by p plus 2, we have 8p plus 16. And after subtraction, it will give us 0. So we have exact divisibility, and this polynomial, which is actually this polynomial, is divided by p plus 2, and result is this polynomial, which is actually this polynomial. So we write polynomial in denominator as p plus 2 times p squared minus 3p plus 8. And we have great cancellations here. And result of our problem will be p. So our complicated example of transformation is equivalent to p. Thank you very much for your attention. Don't forget to like us and subscribe.